Today's lesson is on inverse functions. We use the notation f inverse with the little -1 of x. But before we get started, how about our riddle? What can run but can't walk? What can run but can't walk? Water. Water can run. You can run the water. Okay. F inverse of x does not mean the reciprocal. It does not mean the reverse. It means to undo. So in other words, if we're trying to solve an equation and get x by itself, the inverse gives you the directions to solve. For example, let's say we have f of x equals 3x minus 5. If I were trying to get this x by itself, the first thing I would do would be to add 5 to both sides. And then after I did that, to get the x by itself, I would divide by 3. Okay? Listen to what we said to get x by itself. If we start with an x, we add 5, then we divide by 3. So this would be the inverse. Now, while it seems very easy to me to know that this is the inverse, I have a few steps that I'm going to show you in a moment. But first, let's see how to determine if two functions are inverses of each other. Recently, I taught you about composition of functions. So we're going to use this to understand this theorem about inverse functions. If two functions are inverses, then we can put them inside of each other and we'll get x. So, are f of x and g of x inverse functions? Here's the test. F composite g of x, which means put g inside of x. So g of x is all of this. And now we go to the f of x machine and substitute all of this in for the x. If this equals x, then we've completed the first half of the test. And absolutely, I can see it equals x. So the first half, or the first condition, is met. But now we have to go reverse and see if we get x again. If we get x again, then we can say that these are inverse functions. So now I'm going to take f, all of this, and I'm going to plug it in here. So I'm doing g of 3x minus 4. And now I'm going to plug that 3x minus 4 in for x. So all of this in here, okay, I still have a plus 4 here. And on the bottom, I have my 3. So now, does this equal x? Boop, yep, there's the x. So since they both equal x, now I can say f of x and g of x are inverse functions. They're inverses for each other. Later in pre-calculus, you will learn about one-to-one functions and all of that, and you can look at the graphs and tell. Here's an easy way for finding the inverse. Follow these 4 steps. you're going to start by replacing f of x with y. Then you'll switch x and y, solve for y, and then get rid of the y and put f inverse of x. And I'll show you how easy it's going to be to follow those steps. So we're going to find the inverse of this function. So I'm going to take f of x and replace it with y. That's step 1. Step 2 says switch x and y. So make that a x, make that a y. Now I'm going to solve for y. And that gives me, undid the wrong thing. So I get y equals x over 4. Last step says replace y with f inverse of x. And now that's my answer. That's the inverse, or you could write it as 1/4 x. So either of these answers, and notice it makes sense. If this is 4x, then 1/4 x. They undo each other. And you could double check it by plugging the 4x in for x and see if you just get x and vice versa. It'll work out great. Now let's find the inverse here. Step 1 says replace f of x with y. Step 2 says interchange the x and y. Step 3 says solve for y, which means get y by itself. So now I have y equals all of this, and our final step tells us to change the y to the inverse notation. And you can write it like this, or if you like, you could split it, put both parts under over 2. So these are equivalent, and either format would be a great answer. Alrighty, our final example. First step, we're going to find the inverse. So that's going to be y equals 3x minus 5. Switch the x and y. Oh, that becomes a y now. Solve for y. And already, hopefully, you start getting used to this process. And now you see we have our inverse. Now this says graph both on the same coordinate plane. If we graph this first f of x, we start at -5 on the y-axis, rise 3, run 1. Rise 3, run 1. So that's f of x. Now, f inverse of x. Let's graph that. I think it'll be a little easier for me if I split it. And now I'm going to estimate where to start on the y-axis. This is 1 2/3, approximately 1.67. So that'll be about 6, 7 will be there for my y-intercept. And now my slope says go up 1 and run 3. Up 1 and run 3. Up 1, run 3. It's about like this. I missed my point a little bit. Let's try that again. Close enough. What I want you to know is there's a reflection in that perfect diagonal right here. This line is known as y equals x. And later, that's going to mean a lot. We're going to see that all the points, the xy's are switched for each and every point. So it's going to be pretty interesting. We'll talk about that later.